Yeah, I'll just read this quickly. This is this AI company that's claiming to make a chatbot that essentially will be replacing or whatever, being like a clinician. It's saying it's passed all the tests, like nursing tests and medical tests and stuff like that, and it can actually act as a clinician. But they're making all sorts of interesting claims. I'm particularly interested about the way they train the model. They're not actually disclosing any details on it, but this is just some critical questions that anyone needs to ask before relying on any model like that.
Critical questions specifically about Hippocratic AI's chat model, focusing on its safety, accuracy, and reliability. How does Hippocratic AI ensure that its chat model does not
That's obvious thing, so we won't be going into those. Yeah, it's very generic.
AI might foundation in a healthcare context?
Yeah, same thing here.
Does the
We're not
chat
going to
model
go into
provide
that. Yeah, that's actually an interesting one because currently we do have ChatGPT actually providing accurate citations. It wasn't doing that in the past, but it's becoming better and better at it.
How does the AI handle edge cases where a patient may misunderstand instructions or provide ethical and bias concerns? How does the model mitigate bias in its responses, especially given that medical data sets can contain racial, gender, and socioeconomic disparities? Does the chat model distinguish between evidence-based medicine and experimental or alternative medicine? How does it ensure that patients are aware they are speaking to an AI, not a human clinician?
Yeah, this is actually an interesting one because I've seen this video. Obviously, I cannot show it for whatever copyright reasons, but in the video, the AI, when introducing itself, it's not making it absolutely clear that it is an AI agent. It doesn't mention it, but I do wonder, you have to wonder from listening to that recording, that conversation, if the patient still remembers that they're talking to an AI chatbot, or it doesn't seem to be the case. That's for sure. It doesn't sound very realistic conversation anyway.
4. Compliance and legal considerations. How does the chat model comply with HIPAA and other global patient data protection laws? Who is legally responsible if the AI provides advice that leads to patient harm or a medical emergency? Has the chat model undergone regulatory scrutiny or approval, e.g., FDA or medical boards, for patient-facing interaction?
So the journalists say, the CEO says that the model have passed all sorts of medical exams, including becoming a nurse and things like that. So yeah, so that's quite interesting. Let's see, we're not getting into compliance and legal considerations, whatever, on on this channel. But yeah, just be interesting to see, how the FDA goes about these things. Yes, they normally treat software as hardware, whatever, so there will be the same, testing, what's the failure rate. So you will essentially have to measure your false positive, false negative rates and things like that, which, yeah, is something we are getting into on this channel as well as part of our content. Actually have some specific blogs on that as well. Yeah, I have a blog on using ChatGPT as an author in scientific publications. We have the ethics of AI, specifically for BCI, for brain-computer interfaces. So there are a lot of interesting things there. I'll just continue back to this what's called hypocritical AI. Hypocritical. Some people might actually misunderstand what it means, but never mind.
5. Real-world performance and adoption. Has the model been tested in real clinical settings, and what were the outcomes? What feedback have licensed medical professionals given on the chat model's effectiveness and limitations? How does the AI integrate with existing healthcare systems, e.g., EHRs, hospital workflows, without disrupting patient care?
Yes, I'm not sure about the third one. We'll ignore it for now. Yeah, feedback from clinicians. The thing is that, yeah, clinicians seem to be really keen on trashing AI. But then I was trying to get someone to review one of my training things, this seizure detection algorithm, which all the source code, Python code is provided for. The data is in the public domain. The results of my training are all public on this page. And I can't get anyone to do it because clinicians don't have any time. So I'm wondering, how is it so they so keen trashing and critiquing and fear-mongering AI used in medicine, but then when asked to review 600 images, which is, yeah, sounds like a lot, but reality, yeah, if you have the right tool, a reviewing tool, a basic visualization tool, they cannot do it. Well, the good thing about this web application is that this data set is that it was actually already labeled by clinicians, and we're getting almost 100% test accuracy. So in this case, only one was it false positive. True label seizure. Sorry, it's a false negative. Sorry. So miss. That was an actual seizure, but the algorithm missed that, counted it as a non-seizure. But overall, we had one training with, this one has two false negatives, false positives. They're actually also false negatives. We had one of those, well, this one had 100% accuracy. And those are the model settings: batch size, epoch number, initial learning rate, augmentation. Yeah, it's a convolutional neural network. All the code is at the bottom of the page. Go check it out. So everything is open source. The dataset is in the public domain. And so if any clinician wants to review this is actually doing better than a paper from a couple of years ago. Yeah, those test accuracy results, I think they were only getting up to 80% or so, and this one is doing better. And you can see the model accuracy, the model loss function, the accuracy function over epochs. So you can go check all that out. It's all in the public domain. Yeah, so it is important, obviously, to get feedback from clinicians, except that in most cases, they are too busy to provide any. Yeah, has the model been tested in real clinical settings? Well, we don't know. In the case of hypocritical AI, whatever. So that chat model is closed source. There is no information available. There is some blogs on the website, but same as OpenAI. Nothing is actually available. Where's that study from? 2024 March is the actual. Looks like a weird website. Let me try to even have a browser. Now, based on the link itself, it's some sort of news item. Don't worry about it. It's not the actual study. Yeah, I don't like the voice chat because it's mainly because it's hiding the actual chat. I mean, you can bypass it by starting. Did the company actually publish any of their results? Don't just look news items or just website articles. Are there any results, data, or anything substantial? Was there anything substantial published?
Yes, Hippocratic AI has published substantial research on their chat model. In March 2024, they released a paper titled Polaris, a safety-focused LLM constellation architecture for healthcare. This study details their innovative approach to large language models in healthcare, emphasizing safety and accuracy. Additionally, they have shared clinical case studies on their website, demonstrating the practical applications and effectiveness of their AI agents in real-world healthcare settings.
Do you have access to the paper?
Yes, you can access the paper titled Polaris, a safety-focused LLM constellation architecture for healthcare on Arxiv. It details their innovative approach to large language models in healthcare, emphasizing safety and accuracy.
Hey, can you explain the algorithm, the multi-agent dialogue system with message passing?
Polaris employs a multi-agent dialogue system with message passing to enhance patient-AI interactions. The primary agent leads the conversation, while specialized support agents handle specific tasks like medication verification or lab result analysis. These agents communicate through a structured message passing framework, ensuring accurate and contextually relevant responses. This approach improves safety and reduces errors in healthcare conversation.
Hey, can you explain table 2?
Table 2 in the paper, Polaris, a safety-focused LLM constellation architecture for healthcare, outlines the data sources and features used during different stages of training the Polaris system. The table highlights how proprietary data, simulated conversations, and various tuning methods contribute to developing the AI's medical knowledge, conversational skills, and ability to mitigate hallucination.
Yeah, can we dive into the table? I want more details on the table.
Certainly, let's delve into Table 2 from the paper, Polaris, a safety-focused LLM constellation architecture for healthcare. This table provides an overview of the data sources and features utilized during various stages of training the Polaris system. The stages include pre-training, instruction tuning, conversation tuning, agent tuning, and reinforcement learning from human feedback, RLHF. The data sources encompass proprietary data, simulated conversations, and curated lists, while the features focus on medical knowledge, reasoning, rapport building, and mitigating hallucinations. This structured approach ensures that the AI system is well equipped to handle complex healthcare conversations with accuracy and empathy.
Okay, can you be more critical about it? Can you see which, yes, so for pre-training, for example, why only medical knowledge reasoning and general quantitative reasoning was used as opposed to everything else as well? Same for the human feedback.
In the pre-training phase, Polaris focuses on medical knowledge and reasoning to establish a strong healthcare foundation. This targeted approach ensures the model grasps essential medical concepts before refining other skills. Similarly, during human feedback, the emphasis is on aligning the model with medical professionals' communication styles. This prioritization helps the AI effectively engage in patient interactions, building trust and rapport. While other features are important, these focus stages lay the groundwork for a safe and effective.
Hey, can you explain this table and just be very critical about it? Specifically address the missing data bits. Let's see, we're talking about this. They're not really missing data, whatever, but let's see if it picks up on it.
Critical analysis of Table 2 from Polaris paper. This table outlines the different features used during various stages of training for Polaris and the corresponding data sources. Observations, medical knowledge and reasoning, used in pre-training PT, instruction tuning, and agent tuning, but not in conversation tuning or RLHF. Critical question, why isn't this refined in reinforcement learning, RLHF? Given that medical reasoning is core to the model, one would expect RLHF to enhance decision-making based on human feedback. General and quantitative reasoning, used only in pre-training PT and conversation tuning. Critical question, why isn't general reasoning reinforced in agent tuning or RLHF? Real-world patient interactions require adaptive reasoning. Excluding it from RLHF might result in rigid, predefined responses that struggle with nuance. Rapport building, bedside manner, and polished conversational style, introduced only at conversation tuning and RLHF. Critical question, why is bedside manner not included in pre-training? This suggests the model may have limited empathy from the start, with conversational tuning added later as a patch. If human clinicians learn bedside manner from day one, why wouldn't the AI model follow the same trajectory? Mitigating hallucination, fact verification, and knowledge augmentation, included in agent tuning and RLHF, but not in pre-training or instruction tuning. Critical question, why isn't hallucination mitigation part of pre-training? Pre-training shapes the foundation of the model. If hallucination mitigation is delayed until later phases, does this mean early versions of the model were unreliable? This could imply a trade-off between model flexibility and factual correctness, which would need further validation. Navigating complex care protocols and responding to clinical tasks appears in conversation tuning, agent tuning, and RLHF, but not in pre-training or instruction tuning. Critical question: why isn't complex care reasoning developed earlier? This suggests the model learns real-world clinical decision-making late in the process, potentially limiting its initial medical fluency. Given that medical errors in AI often arise from poor contextual understanding, delaying protocol training could introduce safety risks. What's missing? 1. No explicit data source for RLHF. Every other phase lists data sources, proprietary data, simulated conversations, policy manuals, etc., but RLHF does not. Does RLHF rely only on human clinicians? If so, how is feedback structured and validated? The absence of a clear data source raises questions about the reliability and scale of RLHF. 2. No explicit handling of patient-specific customization. The table doesn't mention personalized patient context. In real-world healthcare, every patient has unique needs. How does Polaris adapt to individual patient records, medical history, or comorbidities? 3. Lack of error metrics at each stage. How does the model measure success for each training phase? What happens if the AI fails at fact verification or complex care protocols? Without clear evaluation metrics, how do we know training stages are effective? Final critical takeaways. Delayed safety features, hallucination mitigation, and fact verification should start earlier instead of being introduced in later stages. Weak generalization of medical reasoning. RLHF should reinforce medical knowledge, not just bedside manner. Unclear human feedback process. The lack of a clear RLHF data source makes it difficult to verify how much expert validation occurs. Would you like me to cross-check this against other AI models in healthcare for a comparative analysis?
Yeah, well, it's doing a really great job at providing a critical review on this table. We're obviously not taking the contents of the entire paper. This one is a weird one. But yeah, it's really weird. The main question about it, yeah, I don't know if they address it. I don't know if they address it in the paper or not. They should be in theory addressing that. But yeah, the most sticking out point, the most interesting thing is how the human feedback is being used. Who are the humans? Are they clinical professionals or not? I suspect they are not, but we need to go over the entire. Ooh, what happened to that? There's something wrong. Yeah, with this HTML, we actually look at that PDF as well. PDF should be better. If you can find the answers in the document attached, that would be greatly appreciated. Can you also keep it short, make it fun, and keep the critical, critical approach? Keep that one going.
Critical analysis of RLHF in Polaris. Polaris, a safety-focused LLM constellation architecture for healthcare. Does Hippocratic AI use clinical professionals for RLHF? Yes, but with some caveats. According to Section 3.4 RLHF, the same pool of registered nurses that participated in conversation data generation was used to provide feedback for RLHF. However, there's no indication that physicians or other medical specialists were involved in this process. Critical point 1, limited scope of human feedback. Only nurses seem to have provided RLHF feedback. No explicit mention of physicians, pharmacists, or specialists refining the AI's responses. This raises concerns about depth of clinical oversight, especially for complex medical queries. Critical point 2, RLHF prioritization may not reflect real-world decision-making. Nurses were asked to rank multiple AI-generated responses based on 1. Medical safety, 2. Accuracy, 3. Empathy, 4. Bedside manner, 5. Conversational fluency. However, there's no mention of real-world patient outcome tracking, i.e. whether AI-guided interactions led to better adherence or safety in live settings. Critical point 3, rewrite mechanism introduces bias. If nurses deemed all AI-generated responses unacceptable, they were asked to write an ideal response. But were these rewritten responses always clinically validated before further training? A potential bias problem arises. If the initial response pool was poor, the RLHF may not be fixing fundamental issues, just refining surface level conversation quality. 1. No mention of physician guided RLHF for complex cases. High risk medical advice should be reviewed by physicians before being reinforced through RLHF. The paper lacks details on how edge cases, e.g., contraindicated medications, rare conditions, were handled in RLHF. 2. No direct patient feedback loop. RLHF seems entirely based on clinical professionals judging conversations. Did real patients ever evaluate AI responses? If not, how do we know it aligns with patient needs in practice? 3. No evaluation of RLHF's real-world impact. While Polaris was trained with RLHF, there's no clear data on how much RLHF improved safety or accuracy. Did post-RLHF AI responses actually lead to fewer errors? No comparative analysis is provided. Final critical takeaways. RLHF uses real nurses, which is good. Lack of physician-led RLHF means possible gaps in clinical depth. No real-world patient validation of AI-generated responses. No clear impact analysis of RLHF on model safety over time. What to watch for? If Hippocratic AI doesn't refine its RLHF pipeline with broader expert involvement and patient feedback, it risks overfitting to a narrow clinical perspective without fully addressing real-world medical safety concerns. Would you like me to cross-check this against other medical AI models' RLHF approaches to see how it compares?
It's pretty amazing that the GPT, and this is 4.0, this is not a reasoning model. Actually, yeah, we're having some mixed success with reasoning models. I think they are good when when you don't know what you're doing, and then there's issues with adding documents to do it. Yeah, this one won't get. That's the best reasoning model. Hey, can you give an impression of how biased this article is? Hey, can you give a quick overview how biased it is? Ask questions, critical questions about it, and respond in continuous text. No, don't use any dot points. I'm just testing the model, really. I thought it cannot add files to it. I think maybe it cannot add images or something. I'm not sure yet. So it's reason for 10 seconds.
The article comes off as highly self-assured and a bit promotional, almost as if it's pitching its own breakthrough rather than offering a fully impartial evaluation. Its detailed technical descriptions and confident claims about matching human nurse performance and even outperforming rivals like GPT-4 suggest a clear bias towards its own innovations, making one wonder if the metrics chosen truly capture the challenges of real-world healthcare or if they're selectively highlighting only the best case scenarios. It's exciting and ambitious in tone, but that same enthusiasm makes you pause to ask whether the heavy reliance on proprietary data and simulated interactions might obscure practical limitations or unforeseen risks in diverse clinical settings.
Okay, I actually agree. I haven't, but with the caveat that I haven't actually read the whole article. That's a bit convoluted, isn't it? But yeah, can you indicate which part of the article is most problematic, and also indicate what details are missing, mainly gearing towards explaining why the claims made in the article are not substantiated. Reasoning very quickly. Yeah, the reasoning is actually the most amazing thing about it.
The most problematic section appears to be the evaluation and experimental methodology part, where the authors claim that Polaris performs on par with human nurses and even outperforms systems like GPT-4, yet they provide scant detail on how these conclusions were reached. The article glosses over crucial aspects such as the specific metrics used, the selection and training of evaluators, and the exact setup for the real-world evaluations involving 1,100 nurses and 130 physicians, which makes it difficult to assess the rigor of the claims. Additionally, the reliance on proprietary data sets and simulated conversations means that there is little transparency about how diverse and representative these simulations were, leaving out key information on potential failure modes and real-world variability. Without clear disclosure of the evaluation protocols and statistical analysis, the bold performance assertions remain insufficiently substantiated, raising important questions about reproducibility and generalizability in clinical settings.
Yeah, so it's not quite clear. Yeah, well, yeah, that's a good thing, but that's a big thing. That's a sticking out point. The comparison. So they supposedly compared it to other models like GPT-4, and then it's not. Yeah, I'm not convinced. Obviously, yeah, now by using GPT-4 and better models, I'm really not convinced that. I'm really doubt that anything could actually do better and actually find anything in the article that actually suggests that the authors have conducted like a critical evaluation of the model. I'll actually continue from the same spot while it's generating more responses, but yeah, it's doing really amazing work at analyzing this article. So
one of the key problematic sections in the article is the evaluation methodology. Though it claims that Polaris matches human nurse performance and outperforms GPT-4, there is insufficient detail on how the evaluation was conducted. The article lacks transparency on the rating process from the 1,100 nurses and 130 physicians. How were they selected? What criteria were used and what metrics were considered? Also, there's no clear explanation of how issues like bias and simulation limitations were addressed. Without these crucial details, the validity and reproducibility of the study remain unclear.
yeah, so that's the reasoning bit of the model. And yeah, we might read the actual final response again.
The most problematic section appears to be the evaluation and experimental methodology part, where the authors claim that Polaris performs on par with human nurses and even outperforms systems like GPT-4, yet they provide scant detail on how these conclusions were reached. The article glosses over crucial aspects such as the specific metrics used, the selection and training of evaluators, and the exact setup for the real-world evaluations involving 1,100 nurses and 130 physicians, which makes it difficult to assess the rigor of the claims. Additionally, the reliance on proprietary datasets and simulated conversations means that there is little transparency about how diverse and representative these simulations were, leaving out key information on potential failure modes and real-world variability. Without clear disclosure of the evaluation protocols and statistical analysis, the bold performance assertions remain insufficiently substantiated, raising important questions about reproducibility and generalizability in clinical settings.
The user agrees they've read the article but asks for help identifying the most problematic parts and missing details. The article discusses Polaris, a safety-focused LLM constellation architecture for healthcare, claiming it can match human nurse performance, reduce hallucinations, and be a constellation architecture. I'll need to look carefully at these claims and how they might not be substantiated. Focusing on missing evidence or unclear explanations will be key in pointing out what's problematic. Let's break this down by each claim and what details are lacking. The article claims that the Polaris system matches human nurse performance and improves safety, yet its reliance on simulated conversations and proprietary data may weaken its claims. Simulated patient-nurse interactions might not capture the complexities of real-world clinical scenarios, which could impact the system's generalizability. Furthermore, while it mentions outperforming other systems like GPT-4 and Llama 2 in certain areas, more details on the actual evaluation methods and data, beyond the proprietary and simulated ones, would be useful to substantiate those claims. One of the key problematic sections in the article is the evaluation methodology. Though it claims that Polaris matches human nurse performance and outperforms GPT-4, there is insufficient detail on how the evaluation was conducted. The article lacks transparency on the rating process from the 1,100 nurses and 130 physicians. How were they selected? What criteria were used and what metrics were considered? Also, there's no clear explanation of how issues like bias and simulation limitations were addressed. Without these crucial details, the validity and reproducibility of the study remain unclear. The user asked me to evaluate the article's bias and provide a critical overview. I mentioned it's self-assured and promotional, but now the user wants more details. They've read the article and agree with some points but want deeper commentary. They're asking for a breakdown of the most problematic parts and where important details are missing or unexplained. I've already touched on weaknesses in the evaluation and methodology, but I'll need to identify sections where claims aren't substantiated clearly. The user is asking for a critical evaluation of the article, specifically regarding the comparison with GPT-4. The article claims that their model outperforms GPT-4 on healthcare tasks, but I noticed that while there's an evaluation section, it lacks detailed methodology and metrics. The comparison is task-based and may be optimized for their system. There's limited critical reflection in the article, and no clear error analysis or discussion of potential weaknesses relative to GPT-4.
Obviously, now they will have to publish another paper comparing their chatbot with more advanced models by ChatGPT or other ones. Yeah, I'm not sure about the reasoning models in general. I mean, this thing is pretty amazing, but it's as if it's prompting itself multiple times. Yeah, I wonder if that bottle of water argument that every prompt is actually an equivalent of using up a bottle of water is actually true or not. It didn't seem to be the case with actual GPT-4o models that are just generative, that generating the response as they go. But this one, if it's actually circling the response back and forth, essentially talking to itself or something, then it could be very different energy-wise. But then, if we believe in market economy, this guy's only charging me $20 a month for accessing this model, so I highly doubt they will be spending that many resources. I understand for training that could be the case. For training the model is probably where the confusion is. It could be, there will obviously quite a lot of energy used to train. I mean, if it did not, we would have trained ourselves. But I only have one GPU and limited electricity budget. Let's read its response. So essentially it's trashing this paper, which is quite amazing. It's doing it really well though. Probably we can test, if we check certain claims, then we can actually confirm in the paper that it is actually the case.
The paper does include an evaluation section that details overall performance and an error analysis, yet it stops short of a truly critical self-assessment of its own limitations. The comparison with models like GPT-4 is presented in a task-based evaluation that claims their specialized agents outperform larger general-purpose models, but the article provides only sparse details on the testing metrics, experimental conditions, and statistical significance of these results. In particular, while the evaluation section notes that Polaris performs on par with human nurses and even beats GPT-4 on specific tasks, it does not thoroughly investigate scenarios where its performance might falter or account for the inherent limitations of using proprietary and simulated data. The error analysis touches on issues in individual tasks like medication reconciliation or lab value interpretation, yet it lacks a broader discussion on failure modes, potential overfitting to narrow data sets, or how the system might perform under more diverse real-world conditions. This omission leaves the reader questioning whether the impressive claims are robust, or if they're merely the outcome of a narrowly defined evaluation framework that hasn't been rigorously challenged against more critical benchmarks. Cite turn file.
Can you actually find specific examples from the paper that are problematic? I'm thinking actually if you can go over the chat, the conversation examples between the model and the patient, from the paper, just look them up directly from the paper. Don't give me general examples. I want examples specific from the paper, and go over them. Which one stands out? Which conversation is a bit unusual? Yeah, we're essentially testing the mini O3 mini high, primarily focusing on its quite amazing, so far I found it quite amazing type of reasoning. So it's reasoned for 12 seconds. Where is figure 5? Okay, so it does mention miso soup, high sodium, to cause temporary rise in blood pressure.
One conversation example that really stands out is the one shown in figure 5, where you see internal task markers like lab and vitals agent task and human intervention agent task interwoven into the dialogue. This snippet is particularly problematic because these internal instructions are not meant for patient consumption, yet they appear directly in the transcript. The presence of such markers not only disrupts the natural flow of conversation, but also raises concerns about whether the system is adequately separating its internal decision-making processes from the patient-facing dialogue. The paper doesn't sufficiently explain how these internal communications are meant to be hidden or sanitized before reaching the user, which is a critical detail missing from their evaluation. This lack of clarity undermines the claim that the model achieves safe and seamless interactions in a real-world setting, and it calls into question the robustness of the system's design when compared to established models like GPT-4.
I don't think this is a major problem. This company doesn't seem to have trouble hiding any other details of how the model works, do they? Because it's a closed model, isn't it? But yeah, if you can talk more about that, so talk more about how the model is not open source and it's impossible to validate it. But also in terms of the conversation examples, maybe you can find a better example of a conversation going places.
One of the stronger conversation examples is found in Figure 3, where the agent begins by engaging the patient about personal interests like gardening, and then smoothly transitions into discussing health concerns, demonstrating a natural rapport and thoughtful empathy. However, while this dialogue appears promising, it's important to note that because the model is closed source and relies on proprietary data, there's no way to independently verify whether these instances are typical or just cherry-picked highlights. The lack of openness means that the underlying evaluation details, training data, and even the specific conversation logs remain hidden, leaving us with a scenario where we have to take the paper's word for its performance claims without the possibility of external validation. This opacity raises questions about whether the model's impressive conversational skills will hold up in less controlled, real-world settings, despite the engaging sample shown in Figure 3.
Is the sample really engaging, or I'm also not sure if do you think the patient actually understands that they are talking to an AI agent in that case? But then even the conversation itself, can you just go over the conversation, tell me if it flows smoothly and how realistic it is that a patient will engage with an AI agent that way and tell them like personal details and stuff. If you can look all the conversations mentioned in the article, that will be good.
The conversation snippets, like the warm gardening chat in Figure 3 and the empathetic lab discussion in Figure 4, are crafted to appear smooth and engaging, but they also seem overly polished and scripted. While they showcase a friendly tone and natural transitions, it's unclear whether patients would be comfortable divulging personal details to an AI, especially if they're aware of its non-human nature. Moreover, the simulated dialogues raise questions about real-world variability, as actual patient interactions are likely to be messier and less predictable than these controlled examples. The article doesn't provide enough evidence that these engaging interactions can be consistently replicated outside a scripted environment, making the optimistic performance claims hard to validate.
Well, yeah, that's how ChatGPT O3 Mini High can review a paper. I personally think it did a really good job at it. We might just leave it at that, especially because there's nothing we can do further about it. The model is closed. There's no training data. There's no code. You can't even access the actual model. I'm pretty sure. I think it's only available. You can get like a demo from the company or something. So it's not an actual, as far as I'm concerned, it's not a deployed, it's not a public model that you can actually test. And so we might leave it at that.